Hello, in this lesson we are going to do the application of derivative, and in real world the application of derivative to motions is derivative of the position is velocity, and the derivative to velocity is acceleration. So we are going to just investigate the movement along a straight line is one dimension movement. So motion on a straight line, then the derivative of the position, it means the change of the position, we call it displacement. The derivative of displacement to the time is velocity. So how are we going to write it is, if we have a function s in terms of t, so t is input, s is output, this is a function, then the derivative of the position s prime of s to the t is our velocity. Okay, this is a definition for velocity. We know how to do the derivative, so we just need to apply the derivatives to find the velocity. And in Leibniz notation, it will write it as v equals ds over dt. And the d is same as our delta, so delta s over delta t. But the difference is when the delta t approaches 0. So the limit of the rate of change is our instantaneous rate of change. That is our velocity. So the speed of the object is absolute value of velocity. What it means is speed is always positive. So speed is always positive, but velocity may be positive, may be negative, depends on the direction. So the acceleration is derivative of velocity. So after that, we could write a equals v prime t, and based on the v prime, vt is s prime t, so we just, so vt prime, then v itself is s prime. So we combine these two prime together, we call it double prime. So s double primes of t is acceleration. And in Leibniz notation, is dv over dt and d squared s over dt squared. So it's kind of, we have the delta squared s over delta squared t. So both of them is double delta, the change of ds over dt. So ds over dt, then another delta delta. Okay, so this is a delta squared s, delta squared t. So d squared, then we normally write the delta t squared. Okay, so now we are going to apply this definition with what we have known for the derivatives to solve the real world applications. So example 1. If a stone is dropped from a cliff that is 122.5 meters high, then its height in meters after t seconds is given in this expression until it hits the ground. After it hits ground, the height doesn't follow this expression anymore. So this formula only works from the stone dropped until it hit the ground. So this is a kind of like our range. Our valid y value is our range. Okay, so 122.5 meter dropped then to 0 meter. So the height, we could write it as 122.5 minus 4.9 t squared. So we are going to see what the question asking you to find. So A, find the velocity and acceleration after 1 second and 2 seconds. So this one is instantaneous velocity. So it's t equals 1 was a derivative to h prime or dh over dt. So it's up to you which notation you like to use. So if we write dh over dt, that is our velocity. So we are going to do the derivative to this function. So constant derivative is 0. And for this derivative, bring the two options. Bring the number degree to the front. So 2 times, then the degree minus 1. So 2 operations, number to the front, number degree minus 1. So we have 4.9 times 2, then t to the exponent 2 minus 1 is 1. So equals negative 9.8 t. So this is our velocity expression. The acceleration, we have v prime dv over dt. So we do the derivative to this expression. We have this is 1, bring 1 to the front, 1 minus 1 is 0. So the t to the exponent 0 is 1. So we only have negative 9.8 left. Then for this question, we are going to write, okay, when t equals 1, subbing the t to the v, we have 9.8 times 1 give us negative 9.8. Because this is a real-world application, we are going to put units here. It's meter per second. And for the acceleration, we sub in the t, it doesn't change. It's meter per second squared. If you have learned physics, you know this is a gravitational acceleration. So on Earth, it's same. Then we are going to find t equals 2. The velocity equals negative 9.8. We sub in the t here is 2. We have negative 19.6 meter per second. Then for the acceleration, it's not changed. It's constant gravitational acceleration on Earth. So this is for question A. Then we are going to see for question B. With what velocity and acceleration will it hit the ground? So it hit the ground means the height equals 0. So in order to find the velocity and the acceleration, we need to find the time. So when the stone will hit the ground. So in this equation, we have two variables. In order to solve for t, the h must be given. So hit the ground, it means the h is 0. So we sub in the 0, then you will have 122.5 minus 4.9 t squared. So t appear only once, so we could isolate it. So for any equations of if the variable appear only once, we could use isolation. So we can just move the numbers to other side to isolate the t. And when you move the number to other side, you have to do the backward of BADMAS. So when solving, you need to do backward. It's from adding, subtracting first. This is adding, subtracting, move that to other side. Do the opposite operation, it will be minus. Then we are going to do the divide, multiply second. So this is multiply with t squared. We do the opposite operation to multiplication is division. Then after that, we have t squared equals 25. So this is exponent. We are going to do exponent. Opposite operation is square root is squared. Opposite operation is square root. So you will have t equals 5 and also negative 5. But negative 5 seconds doesn't exist. We don't know -5 seconds before the stone dropped where the stone is. What happened to the stone? We have no clues. So we ignore the negative time. Then we know that at t equals 5, it will hit the ground. Then we sub in the t value to the velocity. So v equals -9.8. Sub in the 5. We have the velocity when it hits the ground will be -49 meter per second. And acceleration will stay same. It's constant acceleration. So this is done for question B. Then for question C, it asks you when the stone is at rest. At rest means stay still. V equals 0. So we have an equation for V. V is equals -9.8 times t. So now in this equation we have two variables. You want to find the t, v need to be given. So at rest v equals 0. Then you will see t equals 0. So it only at rest when it start to drop. So t equals 0, it at rest. And question D. When is a stone moving in the positive direction? So it means the v need to be greater than 0. So -9.8 times t greater than 0. How to solve this equation, this inequality? We isolate t. When we isolate t, we are going to do the opposite operation, bring the -9.8 to other side. So for inequality equation, how to solve it is same as equation. The only difference is when you multiply or divide a negative number, you switch the sign. Other than that, everything is same. So you divide it negative, you switch the inequality sign to this one. So t less than 0. Time less than 0 is no. We know before t equals 0, we don't know where the stone is. So this one, no solution. So the stone doesn't move in the positive direction. So if find the change of the height of the stone during the first 2 seconds. So the change of the height, we want to find, okay, 2 seconds where the height is. Then we do the subtraction. We are able to find the change of the height. So which one we have the t and h is a given equation. So we are going to just do the substitution. We sub in the h. So we go here. So h equals, so this is question E. T equals 2. We are going to find the height. So the height will be t equals h equals 122.5 minus 4.9 times 2 squared. Do the calculation, we have 102.9 meter. So the change of the height equals 102.9, the final height, minus initial height, 122.5. That is when t equals 0. So it will give you negative 19.6 meters. So the change of the height is down 19.6 meter. Okay, so this is how we use our derivative to find the velocity and the acceleration for the question something free fall. We call this one no external force is free fall. So we solved one free fall question using derivative. Okay, so this is where we can use derivatives in real world application. So now we are going to look for the where we can use if the graph not the equation not given, but the graph is given. So this is a position time graph. So this is position, this is time. So this is go up, then coming back, then go up again. This is position. So question A, it asks you when is the velocity equal 0. So all the object is at rest. So v equals 0. What it means is the slope for your position time graph, the slope equals 0. So we are looking for where the slope is 0. So this slope is positive, positive. This one is 0. No rise. It's rise over run. So rise is 0. Then you will have the slope equal 0. So no up down is 0. This one, we draw the tangent. This point, the slope is 0. So we have read it from the graph. This is t equals 2. Another one is t equals 5. So this is how you find where the slope, where the velocity is 0 at rest. It stays still at that time, at that moment. So when is an object moving in the positive direction? So moving the positive direction, it means the velocity is greater than 0. From the graph, it means the slope equals 0. So how to determine the slope equals 0 is from the left to right is up. This is increasing. Then the slope is 0. So from here, we are going to see this part is going up, so slope is positive. This part is going down, slope is negative. And this part is going up, the slope is positive. So now we could write it's from 0 to 2. And if you didn't take advanced functions, you may not practice enough for the increasing decreasing interval yet, so please practice more on this part. Okay, we have unlimited try on our questions on delta math, so please press click the bottom, keep practicing, then the delta math will give you more questions. Okay, so from 0 to 2, the slope is positive. It means its velocity is positive. Velocity positive means you are moving in the positive direction. So, and also here to here is t greater than 5. So, and I tend to write the interval in maximum, minimum direction. So from minimum for this interval, left, very left is 0, maximum x value is 2, so I just put x in between, less than, less than. So for here is 5, and all the other side is okay, so it's not x, it's t, sorry. The t is 5 less than t, so you could write it just minimum, then maximum. If you want to write it, is infinite. This is interval notation. You also could write another notation is 0 to 2. So minimum, maximum, then put them in bracket. So the curve regular bracket is just doesn't include this point. If it's a squared bracket, then it means include that value. So for these intervals, I'm okay if you don't write this squared bracket. So it's just from this point. You could write it include that point, but we know the left side limit doesn't exist, so you could just write as open bracket. Okay, so this is 0 to 2, then we don't use a squared, okay, because we don't want to include the endpoint yet. So file to infinity, we could write it as file, comma, so minimum first, maximum after. When we write it as interval, this is we call inequality equation. Then it's file less than t less than infinity. This is interval notation, okay? So the question C asks you when the object moving in the negative direction means slope is less than 0 is negative, so it's going down from left to right, going down. This is slope is negative, velocity is negative, moving negative direction. So from 2 to 5, we write minimum, maximum here, then put a variable in between. Use always less than if we write minimum first, maximum after. So that is C and D. Question D, draw a diagram to illustrate the motion. Okay, so this one is one direction. So it's one. So if we define this is positive direction, and we have the position is 0, when it turns, it is 8. So it goes from t equals 0 to 2, it goes all the way to here. So this is from t equals 0 to t equals 2. So it walks all the way to the right. Then from t equals 2 to t equals 5, it goes back to position 4. So if this is 4 from t equals 2, it walks backward. So that is when the velocity is negative. So t equals 5, stop here. Then from 5 to after 5 is going up. So after 5, from this point, it's all the way go to the right, positive direction until infinity direction. Okay, so this is how you draw a diagram to illustrate the motion. So right, go to the positive direction first, then move the backward, then go the forward again. So this is question D. Question E. Use a slope of tangent to decide in which interval the velocity is increasing. So for this part, we are going to draw the velocity graph. So question E, we are going to draw the velocity graph, and how are we going to draw it? We are going to see this is time. So this is velocity, and the first thing what I want to find is we want to find the 0 point. So t equals 2 at rest, t equals 5 at rest equals 0. So velocity equals 0, and before t equals 2 is positive. So it's kind of steeper, the slope is steeper than slowly drop. So it's kind of v is from bigger number than drop to 0. Then from the 2 to 5 is from 0 then negative, steeper than 0. So it means from t equals 2, the slope goes to negative. Once it reaches a highest point, steepest on the graph, then it's less steeper until it goes to slope is 0. Then after that, slope is positive. So slope is positive after that. So this is your velocity time graph. This is a little bit hard to graph. And this point, where this point will be, we are going to see the steepest on this graph. So it's kind of around here is the steepest. So it's we just estimate is 3.5. So if you got other numbers, okay, because it's just approximately. Okay, so then from this velocity time graph, we are going to see when the velocity is increasing, when it is decreasing. The increasing means slope of the velocity time is positive. So this part is positive. So t greater than 3.5, v is increasing. So the slope positive is increasing, then the velocity, if the slope is any quantity, if the slope is negative, then it's decreasing, it's going down. So v t less than 3.5, v is decreasing. So this is a little bit confusing from the original function to draw the derivative of that function. The derivative of that function is just find the slope, then to graph. And the tips is find the 0 point. Find the zeros. So this is a 2 file. Then after that, find is positive or negative or positive, then you just sketch it. So we know t equals 2, t equals 5, they are zeros. Positive is these two areas, this is negative. So positive here, negative down, then you have the graph. This is a trick to how you graph it. And after that, it asks you to decide when the acceleration is positive, when it's negative. So question E, the next part for acceleration. Acceleration, what we are looking for is a slope of v was t, okay? So the slope, if negative, then acceleration is, the slope negative, acceleration is negative. So from a less than 0 is 0 to 3.5. This part, the slope of velocity is 0. Slope of velocity is our acceleration. And a greater than 0 is slope is positive, is t greater than 3.5. So this is how we determine the negative or positive, okay? Then we are going to practice more on the graphing because it seems that if the equation given, finding derivative, we are very good at it. But for graph, from graphing to find the derivative is challenge. It's very challenging, so we practice another one. So it asks you please sketch a velocity time graph and acceleration time graph for the following situation. Go to school in the morning by a car. The car is, so we have a car here. Okay. We have a car here, then accelerate. So this will be the timeline. I think this is, we are going to draw a position line first. Then on the position line, we are going to indicate from t equals what, where it will go. So from t equals 0, the car starts. in 5 seconds. It accelerates to 50 km per hour. So then after that, maintain this velocity after 10 minutes. Reduce the velocity to 0 in 10 seconds. So here will be in 10 seconds. It's 0 km per hour. So now we are going to graph 8. So this is the time. This is the velocity. So we have time equals 5 seconds, and 10 minutes will be 600 seconds. So altogether will be 605. Then after 605, 10 seconds, so it's not in scales. So this is 615. So I will put a break here, okay? So from 0 to 5 seconds, the speed is 50 km per hour. So from 0, jump to 50 km per hour. Then drive for 600 seconds. Maintain this speed. And after that, at the last 10 seconds, the speed go from 50 to 0. So this is our velocity time graph. Then after that, we are going to draw another one, acceleration and time. So this is in seconds. And this one is a kilometer per hour. We could convert it to the minutes per second, but we can just leave it there, okay? So acceleration, we need to find the slope. So the slope, if it's we assume that is a constant. So this is a slope is a straight line. So a will be somewhere here. Is a big number because it's positive. Okay. So it's 50 kilometer per second divided by kilometer per hour, then divide by 5 seconds. You change it to the hours. So I will leave the calculation for you there. So divide by 5 seconds. 5 over 60,3600 hour. Okay. Then we ignore that number. Then after that, stay at the same velocity. The slope is 0. So slope is 0. It means the acceleration is 0. So 5 seconds, 605. Then the last 10 seconds is negative velocity. So positive acceleration, 0 acceleration, then the last part slope is negative, so it's a negative acceleration. So this is how you do the graph from the given situation, okay? So speed change from 0 to 50, then stay same, then drop from 50 to 0. For the acceleration, it's the slope of the velocity time graph. So slope is positive, and if straight line, it means the slope is a constant. Won't change. Stay at the constant speed, acceleration is 0. No rise or run. Slope is 0, so it's here. The last one, they accelerate. The slope of the velocity time is negative, then the acceleration is negative. Okay, so this is our first lesson for application of derivatives. Please practice 3.1 on delta mass. So thanks for watching.